first project that I want to highlight today is our collaboration that we have with the Danforth Plant Science Center, which is funded by the IN2. The hypothesis that's driving this work is that hyperspectral imaging can be used to detect disease presence before the human eye can. If we can detect a pathogen before we can even see it, but we're confident that the pathogen is present in the field, we can be proactive and prescriptive in applying fungicides. The first phase of this project is a lab-based project where the Danforth scientists are using highly controlled conditions to infect specific parts of leaves. And then they're evaluating the hyperspectral images for distinct wavelengths. That's what you see here. This work is ongoing, but promising enough that the agronomist and researcher in me just could not wait to get it out into the field. And so that's what we're working on right now, as Orlando talked about previously. We're looking at a sensor that has 3 spectral bands that's based on that lab testing. And we're also looking at the validation of specific pathogens by culturing samples that we collect directly from these fields to put the whole picture together. While this specific sensor is not in our array at the moment, we see the evaluation and integration of new sensors that will be help us to be more proactive and predictive as a key component of our business. The second project I want to highlight was our collaboration with Rantizo. This was a really exciting project. Using TrueCause, we created a reduced application map that would eliminate upspraying fungicide in areas in the center part of the field that had poor or no crop establishment to maximize product use. So Rantizo, using a swarm of 2 drones, successfully applied Veltima in the middle section of this field on July 29th. A generic product was applied on the left-hand side of the field, and we also had an untreated check on the right. We've been capturing data on this field from the very beginning of the season using aerial imagery and TrueCause. Here we see the NDVI images from the beginning of the season and after application. It's clear that the Rantizo applied Veltima in the middle section has improved the crop health. But we can go even deeper in understanding what's happening in this field. Using TrueCause data, we can look at how disease is present and progresses through the field over time. And we can also understand that the stressed area at the top portion of the field that you see it on the right side of this slide isn't due to a treatment, but due to lack of crop establishment. And this is where we did not apply the fungicide to be sure that we weren't wasting product. But that's not all. TrueCause also has data that gives us depth and understanding of product performance. This figure here shows the average temperature and humidity within the crop canopy with the vertical line as the application date. You can see the larger variations in temperature and humidity that follow application and the differences that are beginning to emerge between treatments. This is just one part of the story, and the yield data that we'll capture will help us tie this whole story together as we look at how directed, precise applications of crop protection products using drones can facilitate efficient and effective crop management. At Aker, we're focused on helping you tell a science-based story with powerful imagery and innovative data. We want to work together to elevate crop production to a new level.